Hello. So this is a tutorial for making a VRChat world with baked light maps using Bakery. Our goal here is to learn some of the terminology associated with making a world look good and give you a high-level overview of what you need to do start to finish to produce a VRChat world. So this is kind of the end goal of what we want to have. We want to have a bunch of distinct objects with light maps or using the baked light probes. And these are separate objects. We're using VRChat's culling. We don't want to combine too many things together so that we can have things pop in and out when we're looking at them with the camera. And we importantly just have a few different materials that we're using here. We want to have as few materials as possible. And that together with the culling and the light maps is going to make a very efficient world that will look beautiful and run well for people in VRChat. So let's take a look at how we start this process to get this result. So before we even get into Unity, which is the program we're going to use to upload the world to VRChat, we need to understand some fundamentals about our models and how our Lightmap UVs are stored on the model, because that's going to be really critical for our baked light maps. So the first part we need to understand is the face of a model. So here you can see a plane. So this has two faces, a front face and a back face, and in Blender we can see both. But if we show the face orientation, we can see the front faces in blue and the back faces in red. And some programs use the back face, but it's important to know that in Unity we can't store Lightmap UVs on the back face. So we can't use the back face for baked light maps. So if we want to make a beautiful world with baked light maps, we can't use the back face. So we're going to want everything, no matter what program we're using, we're going to have to find a way to confirm that all of the faces we're using are front faces. So in this example, we want things to be blue. Anything important has to be blue. And anything else in red is going to be ignored by our light maps. So we have to be okay with that not capturing shadow. Another critical aspect of creating baked light maps is the UVs, and more importantly, the Lightmap UVs. So when we have an object like this cube, you know, we're used to texturing it. We have images associated with that, right? So we're using all of these faces are referencing the same image, and they're displaying it across all their faces, right? And this is fine for textures, but for shadows, that causes a bit of issues, right? Because if we try to paint light and shadow onto one of our faces, then it's going to be on all of the faces, right? So this isn't a good canvas. This is a bad canvas to paint light and shadow on, because it's gonna any change we make to one side is gonna be put on all sides. So these are not good Lightmap UVs to be associated with a Lightmap bake. So once we've decided that we want to make better Lightmap UVs to be able to cast light and shadow onto, we can store that in the second slot. So even within Unity, no matter what program you're using to bring models in, Unity treats the first UV map for the texture and the second UV map for the Lightmap UVs. So we can have the best of both worlds. So I'm just going to generate some Lightmap UVs here. So nothing's overlapping on each other. We have these distinct margins between everything. We can always make those bigger or smaller depending on what we want. If you're having issues where you have dark or light edges, it's because your margins aren't far enough apart from each other. But you also don't want to have, you want to use as much of our image as we can. So you don't want to waste a bunch of space and have big margins with nothing in between. So if we have some good Lightmap UVs, and let's just pretend, so this is what we're looking at here. So now that there's no overlapping faces at all, we are able to paint on one side of the cube without having it anywhere else, because this is a unique face within our Lightmap UVs. I know this stuff is a little difficult to wrap your head around, but this is the most important part of baked lightmaps. If you want to be working with baked lightmaps in Unity, you have to understand Lightmap UVs. Okay, so now that we've got our fundamentals down, I've got our scene here together in Blender. I've individually made sure that these have good UV maps. And we also have these two objects that we've brought in from a different source that are going to have their own UV solutions figured out that might not be compatible with having Lightmap UVs. Like I've got this one here. We've got a lot of overlap here on a lot of these textures. So I'm just going to leave this in, and we'll see how that looks in our end product when we're not able to resolve these Lightmap overlaps here, the Lightmap UVs overlapping. But we have our other one here where I've successfully divided all the little bits and pieces so that nothing's overlapping on itself. Okay, so we have our finished scene here in Blender that we want to bring into Unity. We have distinct geometry, separated objects, so that nothing's too combined together. We're going to let culling do its job, so we want to have separate objects. Obviously, we're not going to divide each and every leaf here to be its own thing. So within reason, we want distinct objects so that if our camera is pointed at one thing, that the other things can be hidden. So most importantly, we have a lot of our geometry here is using the front face. We're not using too many back faces. A lot of foliage uses back facing, but that's going to have to be a decision you make whether you want all of your foliage to have light maps or not. So we're going to export this into Unity as an FBX. Okay, so we're here in the VRChat Creator Companion. We're going to make a new project, a new world project. And I really stress that we want to keep things simple. We're going to try our first project, start to finish, just doing things very simple, okay? So we're going to just leave things as they are here. And the only thing we're going to bring in is Bakery once we get inside Unity. Okay, so now that we're in Unity, we've got the VRChat default scene here, which is really helpful. It sets up a lot of things for us. I'm going to get rid of the light and the floor, and we're going to bring in Bakery from the package manager. So you have to have had Bakery purchased on the Unity Asset Store. Just going to click import to bring this into the scene. Okay, so now that we've got our project all set up, we've got Bakery installed. The first thing I'd like to do is get the default skybox replaced. So I've got a HDRI 2D image here, and we can't use it as a skybox until we set it up as a cube map. So now that it's set up as a cube map, I can drag it onto the scene and it'll be the skybox. But the better way to do this, we're going to create a new material. And the new material is going to be set to skybox. Cube map. We drag our cube map in here. Drag our material on here. And now we can adjust the exposure and rotate the skybox, which is helpful. We've dragged the FBX that we created in Blender into our project. We're going to inspect it in the inspector and set it to read write. Now we can drag it into our scene. And there we go. So we have our FBX, and that includes a light in it actually. So it's using the same light direction as was set up in Blender because it includes the sun that we made there. I'm going to adjust the intensity of the sun so it's a little more reasonable. And you can see the location of the sun here doesn't line up with our skybox. So that would be the next thing I want to do, is I want to adjust the rotation of the skybox so it does a better job of matching where our sun is. While we're still setting up our scene and our objects in the scene, we are going to add a dynamic object that we can use as a surrogate for how the avatar will be lit. So we're going to leave this as non-static or dynamic, and we're going to make everything else static, which is a really important distinction to make. Just anything that's going to be moving around, we want to be non-static, and anything that's going to be staying still that we can make light maps for is going to be static. So we have our scene, we have our meshes, we have a skybox, and we have a directional light acting as the sun, and it's not necessarily the same as the skybox. We have kind of the image of a sun, and then we have what Unity is treating as the sun, right? So those are two different things. But we don't want Unity to light the scene, we want Bakery to light the scene. So we're going to disable the Unity light here, and let's get our scene back to black. So we're going to go into the rendering, lighting, and a lot of these tools are for the built-in Unity Lightmapper that we're not going to be using. But under environment, we can see where it's adding some color to the scene here. So we can just change this to anything where we can get it back to black. Just get the intensity to be 0. We could also change the color to black as well, instead of the color being white. So this is basically, this is trying to fill in the shadows for real-time environments, but we're not using real-time, we're using light mapped. So all of these are just going to be filled in with Bakery. So now that our meshes have good Lightmap UVs, a good canvas to draw on, and all of our scene is black, we have a good starting point. We can now start adding light in with Bakery. And the first way we're going to do that is by bringing the skylight. So we're going to use the skybox to paint the scene based on the intensity and the color of the skybox. So let's do that. So I've got a skylight object. So this is going to sample the skybox. I'm going to match this to match the skybox. And then we can go into Bakery. These are default settings. And we're just going to hit render. Perfect. So we've got our first bake. We have a little bit of intensity from the sun there, and otherwise we just have this nice blue from the sky. So the skybox has painted onto all of the static objects in our scene, and we can see that our light maps have been affected. Now we'd like to add the sunlight, the rays coming from the sunlight back into the scene, and we can use the real-time light just to kind of make sure we like where the shadows are. You know, we can rotate things a little bit to adjust them while we have this real-time light. We're not going to be using this real-time light, but we can adjust things to get a nice starting point. You know, we want to have some color to this light, just like a little bit of like an orange. Nice. Okay, we can go back to disabling that, and we're going to add in on the same object as the sun. We're going to add in a bakery directional light, and we can actually get it to just steal all the settings from the real-time light. So we're not using the real-time light, but we can use it to kind of adjust things, because we can't, the bakery light isn't doing anything until we bake it. So let's see what it looks like with that. We can render our light map again. Nice. So we've got some good intensity coming from the directional light from the sun, and we've got some nice bounces coming off of that, which is a lot more appealing to look at than the previous real-time light. For optimization reasons, it's very important that we make a small group of materials that we're going to replace everything in our scene with, because when we bring in an FBX from Blender or a different 3D program or a prefab, it's going to have all these different names of materials, and we want to be able to let the GPU process all of one material at the same time, and if they're all named different things, that's going to cause some issues. So we want to create an environment where we only have a few materials in the scene, and it's able to render those materials all at once together. So I'm going to go through and replace everything in the scene with our own materials. Once I'm done that, we can see the effect that having colored materials makes for our scene by baking it again. As you can see, our red is bouncing into the scene, so even the objects that are receiving light are their own source of light. They're bouncing light around within the scene, which isn't the same effect we get from real-time light. This is a nice indirect form of lighting the scene. So not all of our scenes are going to be outdoors, and they might not even have sightlines to outdoors. So if we want to introduce light into a scene from a mesh where the mesh is casting light, then we're going to use a bakery light mesh. So we're going to add this component to the mesh just like we did with the directional light and adding the bakery directional light. We're going to add a bakery light mesh to this mesh. So if you have a model of a light bulb, you can add a bakery light mesh to that light bulb to make it cast light into the scene. So let's add some color to that and try it out. So you can see here the mesh is casting light into the scene, but the material didn't actually change. So what the mesh looks like and what it's doing to the scene are two very different things. So we can make a new material just for this, and we can actually get Bakery to change the material to match what the light's doing. And that's going to be a little bit more realistic of a representation of how that's lighting the scene. So we have our meshes, we have some 2D light maps being wrapped around them to give them some lighting. We can examine those in the inspector here. We can see what the actual image is. This is a whole image that has multiple meshes on it. And we can see the shadows that it's casting on it, on the light maps. So let's try to bring this into VRChat. So we need a spawn point, and we need somewhere to stand on. So the VRC world by default just acts as a spawn point. The blue arrow is where people are going to be looking when they spawn. And we'll just make sure that's up in the air, it's up off the floor. And we can actually add a box collider to the floor. And that'll make sure that people can stand on it. To bring this into VRChat, we need to open the VRChat SDK, just like you would with an avatar. We have to give it a name. We need a thumbnail, capture that from the scene. And we can build and test. Okay, so we're in our scene. We can look around, we've got our meshes. Our meshes are receiving light maps. Beautiful. We're walking around. And a couple of things we can notice if we want to start kind of troubleshooting things is I'm not receiving light at all, and neither is this object that we set as dynamic, right? So dynamic things on the scene aren't receiving light. And another thing, this flower here doesn't look very good, and the shadows of it don't look very good either. Those are two different things. So let's go back into Unity and dive into some of these problems to see what's up. Okay, so we're back in Unity, and the reason why our avatar and this dynamic object, this non-static object, are not receiving light is because the only source of light in our scene right now is baked light maps, right? So these objects are static. We've told the game that they're static so that we can paint this light onto them. But since these objects are dynamic, non-static, same with our avatar, we have no way of lighting them right now. So how we're going to solve that is by adding a light probe group. So we've got a light probe group here. And what that's going to do for us is when we bake our lights again, it's going to use these invisible balls to give an example of what the lighting is like for dynamic objects. So now that we've baked with the light probes, this dynamic object has things to reference for its lighting. But you'll notice we only put down one light probe group. So if we go over to the shadows over here, it's still referencing the light probe group over here, right? So it can only reference light probes that we've put down. So that's just where it's getting this very simple lighting information from, and that's what our avatars will receive as well. So let's try putting down a few more light probe groups. Less is more, but we have a few different areas here that have different kinds of lighting. So we'll try to capture the transition between those areas. And let's bake again. Okay, so now that we have more light probe groups, we have more things for our dynamic objects to reference. So they can be hidden in shadows, they can receive darker light. We're even getting a little bit of this blue light that's coming off of this emissive mesh light object that we made. And then when we go over into the sun here, things are nice and sunny. Another issue that we wanted to address is the definition of these shadows here. We have these nice flowers casting shadows, and their shadows are a little bit pixely. So when we open up our light map, we can see in yellow the light map of the mesh that we're looking at here. And we can see that it's only taking up about a quarter of this whole light map. So if we want to give it more definition, it's going to have to take up more room. So we can increase the scale in light map, and then the next time we bake, it's going to take that into consideration. So let's do that now. Okay, so now that our bake is done, we can see that our light map for the ground is taking up even more space within this light map. So that's going to increase the size of the world, and it's going to increase the amount of VRAM that we take up. The last thing we wanted to look at was the fact that this vase with flowers is just not being lit very well. Like, everything's splotchy and there's not light on one side, shadows on the other, like this one is doing. So if we look at the light maps for this, we can see this is the one that's just a total disaster, right? So this is with all the overlapping UVs, things aren't arranged properly. So these are all overlapping. It's getting lit on one side and it's applying the light there, and it's getting dark on one side and it's applying it everywhere. So we can't use these light maps in Unity. We're going to have to find some other way. There's, if you want to look up generate Lightmap UVs within Unity, there are ways to do that. But for me right now, I'm going to leave this as static, but I'm going to tell it to just grab from the light probes as well. And that will solve a little bit of our issue here. Let's bake. Okay, so now that we've removed that from the light maps, so this is no longer using light maps, it's only using light probes, just like our dynamic objects are. So you can see it's receiving shadows, but everything's pretty generic. It's using very generic information. It's not casting shadows on itself. So it's a pretty simple way of lighting things. But you'd be surprised how often you can get away with removing something from the light map and using this kind of light probe lighting instead. So there are a few different reasons why you might want to use that as a solution. But especially here where we cannot use these light map UVs, we're going to have to use light probes instead. In addition to light probes, we might want to introduce reflection probes to help with shiny objects and shiny avatars. So let's take a look at that. Let's add a light reflection probe. So bring this to 0 so we can move it into our scene. So just like the light probes, it's just gonna kind of sample. It's gonna capture a 360-degree photo of the scene so that things can reference that to give a shiny look. And the more angles of these you have, it's going to blend them together. But in general, you usually want one just directly in the middle of a room or a scene. So let's render that with Bakery. Since we're using Bakery for our light maps, we want to use it for our reflection probes as well. And this will clear every time you bake. So let's see how that looks with a shiny material. So it's kind of referencing this 360-degree photo to try and make things a little bit shiny. It's not perfect. It's just something you can use, especially in situations like this, just to kind of capture some of the colors and the visuals of the scene. And avatars are going to use this as well. So the final step before we upload the world is to bake the occlusion culling. So we talked before about how we want these distinct objects so that we only have to render what the camera is looking at. So if we go to Window, Rendering, Occlusion Culling, we're going to get this inspector window here where we can bake the occlusion culling. And if we go to the Visualization tab after that, it's going to show us what the camera is seeing. So we can see the camera here and what the camera is seeing. And when we rotate it, it's going to pop in the things that it's looking at. So you can see that if we're looking off the edge, without we can't even see the floor, it's going to remove the floor. It's not rendering anything it doesn't need to. So as we spin the camera around, we're only seeing what's in the view. And importantly for occlusion culling, if there was objects that are behind objects that we're not looking at, then it's not going to render those either. So it's going to try to, if we bake the occlusion culling, it's not going to show us objects that are behind things that we can't see. See how the red dot is coming in and out of view because it's behind something else. We're pointing the camera towards it, but the occlusion has baked it so that we don't see it anymore. So that's perfect. So after we bake our occlusion culling again, we can upload the world to VRChat. Okay, so now that we've uploaded our VRChat world, we can open the VRChat client and launch it. And this is a beautiful, optimized VRChat world. We've got our baked light maps, lighting objects. We have the light probes lighting some of our objects as well. The light probes are also lighting the avatars. So we're getting good light probe shadows from that as well. We have some reflection probes to sample for shiny objects. And everything's culling. So when I'm not looking at things, it's not rendering things. And this is going to be a very optimized and beautiful VRChat world. So this was just a beginner's video to give you some terminology to get started with. You can see how important the Lightmap UVs are. So that's the #1 thing I would recommend doing research on or watching further videos on, is the Lightmap UVs. And then I'll be making some more videos digging into some advanced options for using Bakery. All right, thanks for watching.